Hi, today we're going to talk about how to use matrices to solve systems of equations. So here's a system of equations that you probably have seen plenty of them. It's two variables, two equations. It does have a unique solution, which is actually 1, 2. We're not going through that. There are methods like elimination and substitution that you can use. We're going to talk about how to use matrix algebra. First of all, we're going to rewrite it in matrix form. So we're going to write it like that. This is called the coefficient matrix. This is called the variable matrix. This is called the constant matrix. You can see where all the numbers came from. There's 2, -3, -4, and 4, and 1, and 6. Next, we're going to find the inverse of the matrix. That involves two steps: finding the determinant first, which is easy to do for a 2 by 2 matrix. That's two different ways of writing the determinant. It's going to be the main diagonal, multiply those two numbers, minus, and then you multiply the numbers on the other diagonal. 4 times -3, and then it's 14. So to find the inverse matrix, we're going to do the following. This is the notation for the inverse matrix. We're going to do 1 over the determinant, and then we're going to make some changes here. The numbers on the main diagonal here, we are going to swap them. So 1 goes here, 2 goes here. And these two numbers here are going to be negated. You switch their sign. So -4 and +3. And then each term in this matrix is going to be multiplied by 1 over 14, which gives you 1 over 14, 3 over 14, -4 over 14, and 2 over 14, which is going to be our inverse matrix. There are a couple of elements in that matrix that we can simplify, but we are not going to do it, because it's actually going to make things a little bit easier in the next step. So here's what we do next. Multiply the equation in matrix form in front by the inverse. It has to be done in front because that's the only way it's going to be possible to do for this side. So here we're assuming here that you know some basic operations with matrices. So when you multiply a matrix by its inverse, you are always going to get the identity matrix, which is this. You are going to keep x and y. So here you're going to multiply this matrix by this matrix. It's a 2 by 2 matrix being multiplied by a 2 by 1 matrix. These two numbers match, so they cancel, and the resulting matrix will be a 2 by 1 matrix. And the way this works, we multiply a row by column. So we multiply 1 over 14 by -4, plus multiply 3 over 14 by 6. And for the second row, we multiply the bottom row by this column, by the same column here, -4 over 14 times -4, plus 2 over 14 times 6. Do the math. If you do the math here, you are going to get 1 on top, 2 on the bottom. You can check this. That's exactly what we're going to get, which is exactly what our values of x and y are. So that's one way of doing that. Another way of doing that is by using what's called a reduced row echelon form. So that, if you do it by hand, it's a little bit more tedious. First of all, what's a reduced row echelon form? You are going to start with an augmented matrix. That's the matrix that you are going to get by taking the coefficient matrix and attaching another column, which is actually the constant matrix. If you remember the original equation, we simply have 2, -3, -4, and 4, 1, 6. And the goal that we're trying to accomplish here is have it written in this form. That's what a reduced row echelon form is. So let's talk about how to do this by hand. Like I said, it's a bit tedious, so bear with me. The first thing we need to do is we need to get this number turned into a 1. So we're going to divide this row by 2. It's going to give us 1, -3/2, -2. And we are going to copy the second row. We're going to label them as row 1, row 2. It's a little bit easier to understand what we do. So yes, we're trying to get this, but it's a certain order in which you need to do it. We're going to need to turn this number here into 1. I'm sorry, into 0. So how can we do it? Well, if you multiply the first row by 2 and subtract it from this row, so what we're doing is row 2 minus 4 times row 1, and that's going to go into row 2. So we copy the first row. For the second row, we're going to do 4 minus 4 times 1, which is 0. 1 minus 4 times negative 3 halves, that is actually going to give us 7. And over here, we're going to do 6 minus 4 times 2, which is 8. 6 plus 8 is 14. Next, we're going to worry about this number. We're going to make it into a 1. So if I divide this row by 7, what I'm going to get is 1 negative 3 halves negative 2. And here we're going to have 0, 1, 2. So we need to turn this number here into 0. Remember this form? So I'm going to continue here. So how can we get 0 out of this? We can multiply this row by, we call this row 1 and row 2. If I take row 1 and subtract 3 halves times row 2, and that's going to go into row 1, I'm going to get, yeah, if I take this, no, I think I should do plus. Yeah, so if I do this plus, so if I multiply this by 3 halves, I'm going to get what I'm trying to do. And that's going to be going into row 1. So row 2 is going to be the same, because we're not making any changes to that. Row 1 is going to be, so the first number is going to be 1. Then we're going to have what are we getting here? We are going to get 0 here, because you multiply, take negative 3 halves plus 3 halves. And over here we're going to do negative 3 halves times negative 2, right? Negative 2 plus 3 halves times negative 2 times positive 2, which is actually going to give you, anyway, you are going, yeah, you're going to get negative 2 plus 3, which is 1. So 1, and these are our values of x and y. Now it's a little bit confusing, especially when you do it for the first time, but we're going to do it one other way. We are going to use a graphing calculator to do this. So I'm going to show you that from the start. Put it in a good position so I don't have any glare. So we are going to hit the, this is TI-84. You might have to check your own calculator how to do this, but graphing calculators are capable of doing that. If I do second matrix, I'm going to get this. If I go to edit and select the matrix, I'm going to get this. So what I'm going to do is I'm going to select first the dimensions, which is, for me, is going to be a 2 by 3 matrix. It's 2 rows, 3 columns. I'm going to enter my numbers. 2, enter. Negative 3, enter. Negative 4, enter. 4, enter. 1, enter. 6, enter. So I have my augmented matrix done. So what I'm going to do next is I'm going to press second quit, because now I need to go back into the matrix menu, but I need to select a different part of that. So I'm going to go back to the matrix. Now I'm going to go to math. And I'm going to scroll down until I see what I need. And I need this option RREF, which stands for Reduced Row Echelon Form. So if I select this, and I go back to the matrix menu and I select my matrix. I press this and you should recognize it from the previous table. This is your X, this is your Y. Okay, I hope this helps. We'll see you next time.